So the last piece of the puzzle here are the so-called arbitrary-arity methods, right? So remember, we've got these different kinds of different types, probably the best word, kinds, types, different types of completable future methods, right? So we've got completion stage methods, then apply, then accept. We've got factory methods, supply async, run async, exception methods, handle, and exceptionally. Arbitrary-arity methods, which we'll talk about in a second. The basic methods, you already know what those are, hopefully get and join and so on. So those are just examples of these different things. And we're going to talk about the arbitrary-arity methods that are used to process futures in bulk. So there are two of them. One is called allOf and one is called anyOf. And as the name might suggest, allOf is basically like an n version then combine. Remember, then combine would wait for the completion of 2 previous stages. Well, allOf waits for n previous stages, not quite the right term, but for n futures to finish. And anyOf, as the name suggests, just waits for one of them, right? So if you give it n, it'll just wait for the first one. Turns out these are really hard to program directly, so much better to use a little wrapper, and that's what we're going to show here. Here are the methods, right? allOf, anyOf. These are the two methods we're talking about. Again, this is sort of the full complement of methods. These are the ones you have for the basic services. These are the ones we have for factory methods. These are the ones we've got for completion stage methods. These are the ones for arbitrary-arity methods. And arity is just a fancy name that means sort of, how many of something, right? So like we talk about unary, which has 1 parameter, binary, which has 2, trinary, which has 3. So that's arity, the number of parameters that are passed in. So we're going to focus on allOf, which you can read about here. This is where we're going to use allOf. However, we're not going to use it directly because it's bizarrely strange to try to program. So here's what we're going to do. We're going to make ourselves a little collector wrapper that's going to wrap up the bizarreness of allOf behind a nice collector interface. So we can just throw it into a stream. Isn't that cool? This is, by the way, one of the coolest things you're ever going to learn in this course, because it's almost impossible to figure this out just by looking on the web, how this stuff works. But it's really, really, really neat and very powerful. So it turns out that there's a collector interface. I think I've mentioned that before. You guys got a little practice with this when you did your array collector. And you have to fill in sort of these methods to do the various operations on a collector that the collector expects. And we just go ahead and implement this thing to make ourselves a futures collector, which just fills all this stuff in. And you can take a look here to find an example of a futures collector. So what the futures collector does is it converts a stream of completable futures into a single completable future that will be triggered or complete when all the futures in the stream complete. And what you're going to get back from this will basically be an array of completed futures. So let's see how that works. And it implements the collector interface to do all this stuff. This is really, really cool. And it takes something that's very complicated but very powerful and makes it easy to work with, right? So that's the Gordian knot with muscles, right? So it's a powerful but complicated thing. So here's FuturesCollector. FuturesCollector implements collector, and it fills in 3 parameters. First is the type of input elements that you're passing in. So remember, we have a stream of completable futures of some type. Type T. It's generic. This is the accumulation type that the collector uses internally to collect each of those completable futures that comes in from the stream. So it's a list of completable futures. And here's what gets returned when we're all done. So when collect is finished with its collector, you will get back a completable future to a list of T. Notice how we took in a stream of completable future to T, but we get back a completable future to a list of T, which is much easier to work with because it's much easier to work with a list of something than a list of completable futures of something. So that's what's returned by something called the finisher method. So here's what it looks like. And a lot of this stuff looks almost identical to the code that you wrote for array collector. Just a few little tweaks, right? So supplier takes an array list, right? Your array collector took an array, right? Because you wrote an array class. So this just takes array list new. So this is a constructor reference that makes a new array list. We then have the accumulator method, which just is list add. So it just adds the item to the list. That's pretty much identical to what you had. Here is the combiner. Well, gosh, that looks pretty much identical to what you had before too, right? You go ahead and take one list of completable future to t, and you have another list of completable future to t, and you add, I should actually have one to another, or one to the other, or whatever. You know, so you basically add them, you add the other at the end of one, and you return one. And then we have the finisher, and the finisher is actually where all the magic happens. So what the finisher is going to do is the finisher is going to convert the array of completable futures, which is what's held internally by the collector, by the collector framework. It's going to convert that array of completable futures into a completable future to a list of completed futures. So let's take a look and see how this works. So what it's going to do is it's going to take the future list, or futures list, and it's going to convert it to an array. And the reason it has to do that is that's what allOf expects. God knows why they did this. allOf wants an array. They should have made it so it took a list also, but they didn't. So you have to make an array from a list. So we go ahead and we make ourselves an array from the list of completable futures that were collected by the accumulator and combine method. And that will then be passed into allOf. And allOf will return a completable future that will complete when all of the futures in the array complete, right? And they're all off running asynchronously in the background, doing their thing concurrently, right? So we get back a completable future that will become triggered or complete when everything else is done, right? So it's the multiplexer effect we're just talking about. And then we call then apply, and then apply will be run when that single future completes. And what it does, and this is just too cool for words, it takes the original list of futures, all of which are now complete, right? Because we never get to this point if they weren't all done. It turns that list of futures into a stream, calls completable future join to convert the completable future value to the value, right? So it's going from future to value of type t. And this code will never block. The join will never block because we couldn't block because we never would have gotten called if anything was still incomplete. And then we collect all of those now values of type t into a list of those things. So we end up getting back a list of, we get back a list of completable futures to t. So, sorry, I'm sorry. We get back a completable future to a list of t. So then apply returns a completable future. So what you end up getting back there was this completable future, which we can then wait on. And let's see. Let me just go back here to remind you how this all came together, because it's easy to lose track of the big picture when you're looking at the details. So this method called toFuture, which I'll show you in a second, that returns this thing sets everything in motion such that collect will return a single completable future, which when complete will have an array of results. So that's how that all works together. And this is actually quite important for your assignment. So knowing how, I didn't ask you to write this code because this is way 6th degree black belt, completable future wackiness, but you'll have to know how to use it. So this call doesn't block, and then it just turns it into a list of type t's, all of which are now done. And notice how none of the code here blocks, right? This is so freaking cool. There's no join. This join doesn't block. These joins don't block. This just gets called back after all the other futures complete. There's something called characteristics, which just says we don't care the order in which these things are managed because it doesn't matter. It's just when they're done, they're done. We don't care what order they're done in. And then we also have the factory method that makes ourselves a new instance of the FuturesCollector. And we do that just so that we can call this thing over here in a very canonical way like that. So this looks very much like toList, right? If you remember using toList for a collector, we just call toFuture. We're going to get a future back, right? And if you really want to be cool, you can use the static import feature and get rid of FuturesCollector and just say collect to future. It's even more like the normal handling of collectors from a collect method. Okay, any questions about that? Yes, Joe. Great question. So if we were to go back and look at the code here, you'll see that all these things, well, actually, if you take a look at this, example 8, what it does is it starts all these methods off in parallel, and it just then says read. So at the very end of main, it just says read. So as long as you don't hit return, all those guys are all running out concurrently. There's no calls to join anywhere, and it just happens if you wait long enough. I mean, if you hit return right away, the program will shut itself down. But if you wait long enough, it'll just all complete. All the results will be spit out, and then you hit return, and you're done. If you didn't want to have to hit return, you would just call join at the very, 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 very end. And that's how your program, your assignment 3A will work. There's going to be one call to join that's at the end of the perform crawl method. But other than that, it's just all running asynchronously. So it's really cool. Okay, so that's basically the end of that discussion.